Let's cover 4.7, which is about geometry here. We're trying to get you to understand what's the difference between parallel lines versus perpendicular lines. We will be conducting our own investigation, and I will have questions for you to answer as part of your homework assignment, so please listen very closely as we cover the lessons. Now, the first word that I want to discuss with you today is the word parallel. I'm pretty sure that a lot of you have heard or used this word before, but I thought I need to cover this with you again, the word parallel. Well, parallel, as it's stated, means that you have two lines that are going side by side, will never cross, right? They would never cross each other. So going side by side, okay, so an example of that is simply you can just draw any two lines as long as they never meet. These two are called parallel lines. Okay, and vice versa. When we talk about perpendicular, we are guaranteed that these two lines will cross over at some point, but they don't just cross over at a point. They have to be exactly 90 degrees when they meet. Okay, so they will cross over at exactly 90-degree angles. Okay, so when you draw something like that, you say one line, you just go and fill it in, and the other line has to cross through it at exactly 90 degrees. Okay, this is what we call perpendicular lines. So we'll try to investigate today to see what's the difference between the two. I first want you to go ahead and plot these 4 points for me and then try to connect them. So let's take a look at the first example I have for you and be ready to answer this first question from the homework. Pretend I have point A to be 0, 1, point B to be 2, 4. This is our, when you connect these 2 points, let's call this line L1, line 1, okay? The second point will be connecting through these 2 points. C is going to be at 1, negative 2, and D at 3, 1. So we'll call this line 2. So let's do a quick graph here. Let's plot 0, 1. For those of you who are weak at graphing or plotting points, please pay attention. Once again, when we're graphing, we're doing horizontally first, left to right, before we move up or down. So if I'm plotting point A, I'm looking at my first value here. It says 0. That means I'm not moving left or right. However, the 1 here tells me to move 1 up. So in this case, that is point A. Point B tells me to move 2 to the right and then 4 up. So that's point B. I have point A, point B. I can quickly connect these two to form a straight line. Okay, so I got my straight line. Let's do point C. Point C tells me to go 1 right, 2 down. Okay, so there it is. And then point D tells me to go 3 right and then 1 up. So here's point C, here's point D. Connecting these two again, I have another line. So let's call this line 1. Let's call this line 2. Now that we have our two lines, let's investigate. I'm telling you right now that L1, line 1, is parallel to line 2. My first investigation will be, well, if they are parallel, what will be their characteristics of parallel lines, right? So I want to go ahead and ask you to look at the slope of each line. Okay, so let's investigate line 1, the slope of line 1. Let's cover that. Here's the slope of line 1. I'm just going to subprime that to be the slope of line 1. Remember how we do this, right? We just set it up vertically. Here's 0, 1. Here's 2, 4. We're subtracting this. So that's going to give us 0 minus 2, which is negative 2. 1 minus 4, which is negative 3. And our slope tells us to do rise over run, so that means y over x. So it's going to become -3 over -2. They're both negative, so they become positive answers. So the slope for line 1 is 3/2, which is correct. It's positive slope. Let's do the same thing for line 2, which is, we'll call that M2. I'm using these 2 points, C and D. So here we go. 1, -2, subtract 3, 1. Okay, I'm using point C and D for line 2. So here's 3 and 1. Let's set it up and start subtracting again. 1 minus 3, which is -2. -2 minus 1. Don't forget, the minus outside applies to both. -2 minus 1 is -3. And as I write it, rise over run again, you see that it's going to be -3 over -2. So therefore, my answer is 3/2. So my first question is, write this down because you need to answer this yourself. What do you notice about the slope of 2 parallel lines? Okay, let me repeat that. First question, what do you notice about the slopes of 2 parallel lines? Okay, all right, well, let's go through our second example. So this time, I have point, let's do another points here. Point E will be 1, -1. Point F will be at 3, 0. Okay, so let's call this line 3. Point G, I'm going to have it at 3, 2. Point H will be at 4, 0. Okay, I'm going to call this line 4. So let's graph these two again, just like always. We'll have point E first, which is 1 over, 1 down. Okay, so this is point E. F is 3, 0, so that means I'm going to go 3 to the right, and then that 0 tells me to stay there. I don't need to move up or down. So this is point F. I'm going to go ahead and connect these two to form one straight line. So I got, this is line 3. Let's do G and H. G tells me to go 3 to the right and then 2 up. So 3 to the right, 2 up. So that's line G. This is point G, and H tells me to go 4 to the right and then not moving up at all or down. So this is point H. Okay, so I connect these two. And I have my 2 lines. Let's label this line 4. I want you to do the same thing like the previous problem. This time you tell me, I'm not going to show you how to find a slope. I want you to find a slope of M3. Tell me what that is. And I want you to tell me the slope of M4, okay, which is for line 4. Set that up. Remember how we set this up, right? We have our vertical subtraction, just like that. I'm just trying to give you a structure here so you know what to do. And the question that I'm going to ask you for this one is the same. What do you notice about the slopes of 2, well, in this case, let me tell you specifically what they are. Line 3 and line 4, they are perpendicular. So what do you notice about the slopes of 2 perpendicular lines? Be ready to discuss this when you come back to class tomorrow, okay? Because I'm going to be discussing this with you in class. Make sure that you know how to do this. So get ready to answers. I want you to find out what is the slope of line 3 and the slope of line 4. I want you to tell me how are they different or the same, whatever. You know, tell me about it, the characteristics of these 2 lines compared to the previous 2 lines, line 1 and line 2. All right. So let's continue with our lessons here. So based on the first example, you kind of notice that for parallel lines, the slopes of 2 lines are exactly the same. Okay, so this is kind of quick review here. So kind of give you the answer for that. but the reason I need to show you now is because we need to be able to write an equation of a parallel line. So notice parallel lines have same slopes. So pretend this. Pretend I gave you an equation of a line, okay? Let's have this as a slope-intercept format. Remember, slope-intercept format is y equal mx plus b, right? So if I ever give you a form like this, you know that it is in the slope-intercept format. So pretend I have this there, okay? This is the equation of a line. We know how to graph this. Let's just graph it for review here. How do we graph this? We always plot the y-intercept, right? This is -2, and the y-intercept means 0 for x, and of course -2 is for y. We always plot our first y-intercept, so it's going to be 0 left to right, and then down 2. The slope tells us that it's going to be -2 over run, right? So that's rise over run. So in this case, I know I'm going to be going down 2 and then 1 unit over. So I got my 2 points. I connect these two, and there you have it. The line of this equation is right there. Okay? Now pretend along with this, I ask you to do an extra thing. For example, I'm asking you to go ahead and find another line, an equation of another line that is parallel to the previous line. Let's call this line 1. I want you to find line 2 that is parallel to line 1. Okay, so I'm giving that symbol parallel line to line 1, and that my line 2 has to cross over this given point. Let's call this point 4, 1. So I want my second line to cross through this given point right there, 4, 1. Okay, so kind of visually, you know that your second line, in order for it to be parallel, it has to look something like this. Is that true? Okay, so I know that my line has to look like that for it to be called parallel. And based on what we learned in example 1, we know that parallel lines will have the same slope. So in other words, if we know our slope for this line, we can also apply the slope to the second line as well. Do we know our slope of the first line? We do, right there. This is our slope, right? So we know that the slope for line 2, we call this M1 right here for line 1, and M2 is also the same as line 1. And so that means we can use the same exact slope value for line 2. Now, if you recall from my previous lessons using the point slope form, 4.5, if we have a point and we have a slope, we can technically write an equation for any line, right? So now we can certainly write this using the point slope form. Here we go. Just to remind you again about the point slope form. There we go. Y minus y1 equal to m times x minus x1. We have a point. We have a slope. Here's our point. We can use that point to replace x1 and y1. We can use -2 to replace our slope right here. Remember, this is just a structure for us to fill in. And since we have a point and slope, we can certainly plug it in and solve. So y minus y1, which is 1. M, in this case, the slope is the same thing as line 1, so we can use -2 for it. And x1 will be 4. I solve for this one right here. Y minus 1 equals to -2 times x, I'm just distributing, plus 8. And I add 1 over. That will be y equals to -2x plus 9. So this right here, guys, is the slope-intercept form of line 2. So the equation for line 2 is y equals to -2x plus 9. Okay. Now, if I want you to put this back in standard form, a lot of you have forgotten what standard form is. Don't forget, standard form will have the x and y variable to the left-hand side, a constants on the right-hand side. So that means we need to move this -2x over. So we add it over. That means you can have 2x plus y equals to 9. And since this 2 is already positive, we can leave it like that. We only need to change it to positive when it was a negative. So in this case, this is what we'll call the standard form of line 2. Okay, so on top of perpendicular line, it is the same concept. We are still using the same exact format. However, the slope is going to be a bit different. That I need you to discover yourself when you come back. Please, answering all the questions that I asked you, throughout this lessons, and I'll be asking or checking you in with you on that tomorrow. Okay?